Hi viewers, welcome to LMO Solution. Today we are going to see about solar PV based electric vehicle charging with G2V and V2G mode of operation. So this is a Simulink model we developed for this solar PV based electric vehicle charging along with the V2G and G2V concept. So this model consists of the main grid. The main grid having the rating of 154 megawatt with the 34.5 kilovolt. So that going to be stepped down to 400 volt. And it having EV battery. The EV battery going to be connected to the solar PV grid via this bidirectional DC-DC converter. So this bidirectional DC-DC converter going to be controlled by means of voltage controller. So here we are going to measure that the DC link voltage. So the DC link voltage going to be compared with the reference voltage. So here we are going to maintain the DC link voltage around 470 volt. So it going to be compared with the 470, and it going to be processed via PA controller, and then it going to be processed via PWM generator. So the PWM generator going to be generate the pulse. So this pulse going to be control this IGBT of the bidirectional DC-DC converter. So here we are going to maintain the DC link voltage at 470, and based upon the energy management or power management, the EV battery going to be charge or discharge. Okay, so the EV battery going to be charged from the solar PV during daytime when SOC is less than 90%. If the SOC of the EV battery is more than 95 during daytime, then the water power generated from the solar PV, so that going to be sent to a grid. So this is a one mode of operation, mode 1. So mode 1 nothing but operation during daytime, that means during the availability of PV power. And mode 2 nothing but vehicle to grid concept. So in vehicle to grid, that means the power from this whole from the EV battery is directly is given to the grid as per user requirement. And mode 3 nothing but grid to vehicle. So this EV battery can be charged from the grid. So there are three mode of operation in this model. So in this mode 1, mode 2, mode 3, mode 1 nothing but operation under power availability in the solar PV. Mode 2 nothing but a vehicle to grid concept. Mode 3 nothing but a grid to vehicle concept. So when this model, right, solar PV rating is 25 kilowatts, 25 kilowatts, and the line to line voltage is 400 in the inverter side, and then grid frequency here is 50 Hz. Okay, so here, so this is a model inside that solar PV system. They having solar panel. The single panel rating is 445 watts. So here we are using 8 panel in series and 7 panel in parallel. 7 strings in parallel. And then here you can see that, so this IV PV characteristics of that considered PV array. The maximum power at a standard test condition is 24.94 kilowatts, right? So it can generate maximum 24.94 kilowatts at the standard test condition. And then this solar PV going to be connected to this inverter or DC link, so via this boost converter. Okay, so this boost converter going to be controlled by means of MPPT algorithm. So here we are measuring the PV voltage and current. So based upon PV voltage and current, the CO2 generate the reference voltage. So here you can see that. So here on the PV voltage and current going to be process via P into MPPT. So it's going to generate the reference voltage. So this reference voltage is going to be compared with the PV panel voltage, and it's going to be processed via PA controller. So the PA controller will be generate the duty cycle. So the duty cycle is going to be processed via PWM generator. So now this PWM generator will be generate the pulse. So this pulse is going to be used for control this boost converter in order to extract the maximum power from the PV array. And same this link, right, we are connecting that EV battery via that bidirectional DC-DC converter. And then here we are having inverter. So here we are having 3-level neutral point clamped inverter, and then we have harmonic filter and a transformer to filter out the harmonic component in the output of the inverter. So this inverter can be controlled by means of feed forward decoupling control concept. So in order to implement that feed forward decoupling control concept, you have to measure the grid side voltage and current, and going to be converted into DQ form by using transformation. So here we are applying that power transformation for conversion of ABC to DQ naught quantity. So after conversion of DQ naught, right, we are going to take only VD and VQ and IDIQ, and then we need to generate the reference current. So here we are going to decide the mode of operation. Okay. So here you can see that this chart or state flow, right, will receive the different inputs. The inputs are SOC mode, and then V2G current and GTV current, and then